These are the video notes for Unit 6 Graphing Level 1. We're going to talk about transformations and stretches and reflections and compressions and what they do to graphs. A lot of this we've already talked about in other units, and we're going to be using these with what we're learning right now. So, horizontal transformations. If you have a function f of x minus h, this is the one where you take the opposite sign. It's opposite of what you think. So you're either going to go right or left. So if it is positive, if it's negative, then you're actually going to go right, so it's kind of a positive value. And then if it's positive, you're going to go left. So for example, if you have the absolute value of x minus 3, you're going to go the opposite. You're going to go right 3. But if you had a quadratic equation, x plus 4 squared, that's positive, so you're actually going to go left 4. So let's do a graph. If we graphed absolute value of x minus 5, would I be going left or right? 5. Right? 5. So my absolute value graph is a V, so I'm going to start at the origin, and I'm going to go to the right 5. 1, 2, 3, 4, 5, and then make my V. Vertical transformations. That's whether you go up or down. So function f of x plus k. We've been using k to tell us whether we are going to go up or down. And it's going to be exactly what you think. If it's positive k, you're going to go up, and if it's negative k, you're going to go down. So if you have the absolute value of x minus 2, you're going to go down 2. If you have x squared plus 4, you're going to go up 4. So let's do a graph. On my graph, if I have x squared plus 2, so I have a parabola. I'm going to start at the origin, and that's a vertical shift. So I'm going to go up to here, and then just draw my parabola. Reflections. Let's get this up a little bit here. If I have a negative on the outside, negative f of x, that would be a reflection over the x-axis. But if my negative is on the inside of my parentheses, f of negative x, it is going to be a reflection over the y-axis. So if I have negative x squared, my parabola is going to open down. But if I have the absolute value of negative x, because of the nature of absolute value, my graph is still going to open up, because the absolute value of a negative number would still be positive. So vertical stretch. Vertical stretch is your A. It's the A outside that's multiplied by f of x, where A is greater than 1. So if you have 2x squared, you're going to have a vertical stretch by a factor of 2. So we're going to, on our graph, we're going to put this on the graph, and this one right here. Here's my origin. It's just going to make it skinny. Remember, if you have a number over greater than 1, your graphic is going to be skinnier. So I'm going to have a skinny parabola. It is going to be vertically stretched towards the y-axis. But if I have a vertical compression, so if I have A times f of x, where A is less than 1, then say for example 1/2 times x squared. This is a vertical compression by a factor of 1/2. So let's graph that one over here. It's going to be fatter. It's going to be kind of pushed down more towards the x-axis. So let's do another graph where we use a couple of different of these things. So if we have a graph, the absolute value of x minus 1 minus 2, what is that going to do to my absolute value graph of the v? It's going to go right 1, and then down 2. So here is my origin. I'm going to go to the right 1 and then down 2. 1, 2. It's not being vertically stretched or compressed. There's no factor here. There's no reflection. And so I'm just going to have an absolute value graph going up, but the vertex has changed. So turn it over and practice doing the problems on the back.